Hi, welcome to Engineering 160A, Studio Session 2.1, For Loop and Waveform Chart. The tutorial objectives are, again, we will generate a sine wave plot, but this time we will utilize a basic for loop and the waveform graph. A for loop executes a given task a specified number of times. This is opposed to a while loop, which needed a condition to be met. If we think about our gym teacher analogy, we said for a while loop it would be the situation where the gym teacher tells you keep doing jumping jacks until he blows his whistle. Well, a for loop, on the other hand, is like your gym teacher just telling you go ahead and do 10 jumping jacks. He's giving you a specified number of iterations in the beginning. The waveform graph differs from a waveform chart in that a waveform graph accepts an entire block of data that has been previously generated. It does not plot data as they are being generated like the waveform chart did. So let's open up a new blank VI and start to build our program. Well, it's going to be quite similar to the one we previously made, but again we're going to use a for loop instead of a while loop. So let's right click to bring up our functions palette. Let's go to structures, and instead of using the while loop here, let's go ahead and select the for loop. So again, click, hold down, drag, and release. And now we have our for loop. Again, we see we have an iteration number, and this will first start at 0 and keep continuing up every time we step through this loop. But now, instead of having a conditional loop, a conditional terminal in the lower corner, we now have this n in the upper left-hand corner, and this is the loop count. And the input to this is the number of times we want this loop to occur. So let's start to rebuild our VI, and we want to generate the sine wave, and we want to do it with a high resolution such that we have step sizes going from 0 to 0.2 to 0.4 to 0.6 just like before. And again, we did that by taking our iteration number and dividing by 5. So let me wire this up and create a constant, make it a 5, and I need to get my sine wave. My sine wave was under mathematics, and then elementary, and then trigonometric functions, and sine wave. Drop that down, and hook up my sine wave, and I wanted to plot it. Now, I don't want to do a waveform chart. I want to try and do a waveform graph. It's a visual type of display. Well, I can't get that from my functions palette in the block diagram. I've got to go over to my controls palette on the front panel. So I move over to my front panel and I right click, and here we have our graph subpalette, and we had our waveform chart, but now we want to learn and use our waveform graph. So let me grab that and let me drop that down. And you can see this looks very, very similar to the waveform graph. So let's go back to our block diagram, and let me grab my waveform chart. And one thing you'll notice is if we try and hook up the sine wave output into the waveform graph, it does not work. And the reason for this, we will see in a bit, is because we need to put into the waveform graph this already built array of numbers. We need to have a bunch of data already in an array sent to this graph. Okay, so I need to build up that array and then send it to the waveform graph, and really what that means is I need to take this waveform graph and bring it outside of my for loop. Okay. All right. So we have to determine how many times do we want this for loop to operate, and let's set that number. So let me go to the input terminal on that loop number, and let me create a constant, and let's use 100 loops. So now let's see how we wire up our waveform graph. We want the for loop to run 100 times, and every time it needs to store the value and create a long array of 100 different numbers, and then we send that to my waveform graph. And that might sound pretty complicated, but it's actually quite easy in LabVIEW. And let's hit Control B That will get rid of all my broken wires. And let me hook up my sine wave, and let me go to the outside of my for loop, and you'll see that there's this sort of terminal that seems to be created. So let me left click here, and you'll see now I've created this terminal on the outside of my for loop, and I can now connect the output of that into my waveform graph. What you see here is that there's very small feature inside here that looks like brackets. Well, what this is doing is this is the tunnel feature, which is auto indexing. So that means it's going to build an array for you. The first time through, it's going to calculate the sign of 0 and store it in the first element of the array. The next time through, it's going to calculate the sign of 0.2 and then store that in the next element in that array. So then when it's finished with all 100 loops, has 100 points inside that data array, then it gets sent to my waveform graph. And I do want to call out here, you can see that the orange line here, the wire, is a little bit thicker than the orange line here. This thin single orange wire is just one number. Through the auto indexing features become an array, and now this thick orange line lets you know it is not just one single number, but it is an array of data. Let's just talk about this tunnel mode here. Let's say we didn't want to have this auto indexing on. We didn't want to build an array. For some reason, we just wanted the last value generated from my while loop. In this case, it would be the sign of 99 divided by 5. Okay, that came into this. Let's say we only wanted to have that value. Well, instead of auto indexing it, we can right click on that terminal and change the tunnel mode. Instead of having it indexing, we can just say last value. When I do that, now you see that the terminal has changed from having the brackets, which denote the array, to just being a solid orange square. We no longer can connect into my waveform graph. And again, this is because my waveform graph cannot accept a single number. So let's go back and right click and bring that into indexing. Okay, so we've built our array. Let me go over and run the program. So here we are back on the front panel. And I do want to change my X and Y axes. If I hover my mouse over the time here and it changes my selection tool into the edit text, I can click on there and now I can change time to say X in radians. And I can do the same thing on the Y axis and change that to saying sine of X. So now I run the program, and you can see the program has stopped because it went through 100 loops, and then only then did it plot everything. We were seeing the data points being generated when we use our waveform chart. But now with our waveform graph, the computer is going to calculate all of the values as fast as it can, and then at one moment display all of the data on my waveform graph. So let's hit run again, and instantaneously it seems the data has appeared. But it's gone through calculating the sine wave 100 times, did that loop 100 times, built an array, sent it out to my waveform graph. Again, we have this same issue where my x-axis is not really to scale, and that's because I don't have my multiplier in there, that 0.2 that we needed in our previous program. Well, we could go ahead and go into the properties of my waveform graph and put in the multiplier just like we did before, but there's actually an alternate way in which we can do that. So we'll look at this here. And what we're going to do is create something we call a cluster. Right. Hit Control H to bring up my context help menu, and I click on the waveform graph. We'll see that what I can do is I can put in or create a cluster here where the first number that comes in is x0, or that's the initial value that I want to be plotted. Okay, so let's say in this case I want to plot starting from 0, so I'll make this 0. And then the next entry into that cluster you'd want to be delta x, or the step change. So in our case, we want that to be 0.2 because we're going to go from 0 to 0.2 to 0.4 to 0.6, so on and so forth. And then finally, the last entry into the bundle will be your Y array. Okay, so this is the array of data that's coming from my sine wave. So let's go ahead and create this. Let me right-click on my block diagram, and let me go to Cluster, Class, and Variant. And here we can see there's Unbundle and Bundle. So we want to bundle a bunch of different data types together, and let's select it and drop it down. Okay. So what does this bundle do? It says, I don't care what data type it is, I'm going to put them all together, tie a little bow around it, and then out will only come one wire. But within that one wire has all of these different numbers that we can unbundle or unpackage. Notice I can resize the bundle if I have many different inputs by just hovering over the bottom here, selecting the resize blue square and dragging. So I do want the 3 different elements. Okay, so one thing I want to do is hook up the actual array of data into that 3rd position, and then I want to start to put in some constants here, right? x0, the first position here, I want to just have a constant equal to 0. So let me right click, let's go into the numeric, and let's grab a constant, and that's the value of 0. That's perfectly good, that's what I want. Let me go ahead and grab another one, and I want this to be a value of 0.2, so let me change that. And that, of course, goes into the 2nd position there, and that's my delta x. Okay? Let's say I want to help somebody who's going to be working on this program after I'm done with it. I should start to annotate it. Well, one easy way in which I can do that is I can go to the View Tools palette. Okay? That brings up the tools palette that we spoke about, and instead of having my automatic tool selection on, let me just change this to edit text, and now I have my edit text cursor. I can left click, and now it'll add a text box. So this I can now write, this is the initial x value, and I can put a note down here that says this is the increment in x value. Okay. Alright, let me switch back to my automatic tool selection and get rid of my tools palette here. Alright, now the last thing I need to do is hook this output from my cluster into my waveform graph. So let me click on this wire, hit delete on my keyboard to get rid of it, and now take my output cluster and put that into my waveform graph. Okay, now we have a cluster as denoted by this dotted pink data type, and you see it has changed the color of my waveform graph. So now it knows to take the first element, set that to the initial x value, take the second element, make that the increment, and take the 3rd element, which is actually an array of data, and that's what I'm going to plot. So we can go back to my front panel, and I can now run this program, and you can see all of my data is plotted, and indeed I have a correct x-axis scaling such that one complete sine wave is 2 pi, or roughly 6.28, which you can see here.